We are going to discuss about the classification and tabulation of data in microbiology. In this lecture, we are going to define classification and tabulation of data, and then difference between or difference between the classification and tabulation, and different types of classification and different type of uh, tables. How come they're going to construct and how we can incorporate these concept classification tabulation for the microbiological data, and how come we're going to justify with these concepts. First of all, what is data? Data is nothing but a collection of observation which were collected by the experiment or a survey in the form of numerical figures. And these data is always in a collective sense and never be used in a singular form. So we can say data is a set of data. Just for example, if the 10 patients suffering from Kala Azar, and we are going to again measure their hemoglobin percentage in a number. So we are going to, all these number are nothing but a set of data, and they are measured in a milligram 100 ml for the hemoglobin percentage. And the hemoglobin percentage is a variable or an event. So we can said that data can be of two types, primary and secondary. Primary data, which is collected directly by an investigation or an experiment or a survey. So is again the first time it is going to be collected for the specific purpose. So is a primary data. Like in this example, this data shows the shows the primary level. We are going to measure from the 10 patients. And the second one is a secondary data. If the data is collected from the any other agencies like library, library has a lots of books, and in the books lots of again uh, values are described. So we can use that in a form of reference, and such kind of a data is called as secondary data. In a scientific research, only primary data is used or can be generated. Second one is what is variable? Variable is any of the characteristics, number, or a quantity that can be measured or counted. Like variable can be of two types: qualitative, quantitative variable. Qualitative variable itself, by name, we can say on the basis of their quality, like again like the any of the like age, sex, again this country, birth rate, death rate. These all are a qualitative, quality shows the quality. So is a qualitative variable. Qualitative variable can be of two type, nominal or ordinate. Nominal is a kind of a defined category. Like we are talking about the age. Age is again a nominal. We are defining the category like 10 year, 20 year or 30 year. So is a nominal defined category. Ordinate is a kind of ordered, like again any of the again if we want to talk about the birth rate of a country, whether it's again a low or a medium or a high, or expenditure is again a very less or a less or least. So such kind of again a category, ordered categories, is a ordinate type of qualitative variable. And the other one is a quantitative variable, which shows the number, quantity. It can be of two type, discrete or continuous. And discrete itself is a counted item, like again an integral number is a discrete quantitative variable. Whereas again continuous, we can measure the characteristics, like again there is a continuity, there is again we can give the example again height of a person or the weight of a person, there is a continuity. And if we're going to talk about the again discrete, like again the the income or expenditure of a business, like again a discrete form. So the next one is how come we going to classify the data? Uh, Data is classified after the collection of data is again a raw data, and we can again categorize the data on on the basis of their similarity, resemblance in a form of various classes. So is called as classification of data, and which will go to proceed by the tabulation. Like for example, the bacteria can be classified on the basis of their gram staining, gram positive, gram negative, their shapes like foci, bacilli, spirali, like growth condition like aerobic, anaerobic, and so we can talk about the types of classification is a qualitative, quantitative, or we can again categorize the data in the form of their again multi-variable form. So the qualitative variable, qualitative classification on the basis of their attribute like motile, non-motile, quantitative like again how many again number is there in a number of bacteria in a colony like CFU. So we can again uh, classify on the basis of their quantity and the best in the class interval forms. And the multivariate or two-way, like again we are going to again classify data on the basis of more than one variable like gram status and the shape and the mobility or motility. So such kind of again classification is a multivariant type. After classification, we can again uh, tabulate the data, or how come we're going to again arrange that data or present that data in a form of table, and is nothing but a tabulation just to simplify the data, just to make computable form. We can construct a table, and that table again there is some main components or important component of an table is again first of all the title of should be clear for the data for that table. Then there is again a row and a column. So the row heading, column heading, then body, nothing but a data entries, and later on the footnotes, like again what is again unit, or again what sort of again the any of the initial. So we can again put it in uh, a footnote form. So why we want to tabulate the data? Because we want to simplify the complex data set. And what is the trend of that data? How come we're going to again depict the data? And uh, for the tabulation, after tabulation, we can easily compare the data, or we can easily make a different type of graphic graphs, or any sort of again a statistical interpretation, apply the various type of statistical tool. So for the same, we are going to make a table. So the you can again check how the types of table. You can easily see that this is a simple table in which only one variable is there, that like a bacterial count is again a CFU per ml, and there is a two column in it, and there are again rows in it. So that this table is again is for a bacterial count in a milk sample. And again, first column, we are again showing the types of samples like M1, M2, M3. Three samples are there. And the next column is again depicting the variable like again bacterial count. And here we are again writing down the bacterial number, colony count of that bacteria in that sample. The second type of table is again a two or more variable or again multivariant. Like again, we are talking about the like antibiotic sensitivity of bacterial isolates like uh, uh, E. coli, how much sensitivity or how much resistant it is, we are again depicting by this constructing. So we are comparing the different isolate on the basis of their antibiotic sensitivity. And the in the footnote we can write down the R is again resistant, S is sensitive, I is again intermediate. Again classify that data and then later on we can tabulate. So for the same we can again explain with an example, like again we are going to again collect the data, or the number or the again quality on the basis of their survey or again experiment. So this is the raw data, and this data is again arranged or presenting in a order. If we're going to arrange in a lower to highest form, higher number, so is a ascending order. And if we're going to again arrange in a from highest to lowest, then is a descending order. So in this raw data, we are finding that each number is individual. There is no repetitive number. So such kind of a data is itself is called as individual data. And if we are getting any of the characteristic number or quantity in a repetitive form, there is again repeat of that value, then is called as frequency. Like for example, this we can explain with this example. There are 32 students in a class, and we are again writing down the age of these students. So this is a raw data, or and we are finding that there are lots of again number is repeating. So we can get frequency of each value. So we can again simplify this data on the basis of their frequency distribution table. So we can again generate or simplify and classify this data on the basis of their construction of frequency distribution table. Frequency distribution of table is nothing but if we're going to again arrange and organize data on the basis of their repetitive number or of frequency. So such kind of a table in which we are getting a independent value, that is x value, and their repetitive number value, that is a dependent value, f value. So if we are going to construct data on the basis of their repetitive number or frequency value, then we can say is a frequency distribution table. And frequency distribution table is again of two type: discrete frequency distribution table and the continuous frequency distribution table. In discrete frequency distribution table, we are getting or we are again arranging data on the basis of their integral number. X value is the integral number. We are not getting any sort of a continuity between these again X value. So if the uh, e- uh, each value is a unique value, and or values again in a data set, they are arranged on the basis of their frequency. So such kind of a frequency distribution table is a discrete one. So if we are going to again check how many time 12 year of age of a student is there. So we are finding in this series there are three. So we can arrange these depict on the basis of their tally bar, like three vertical lines again showing that there are three students of 12 age group. Like wise again 13, 4 vertical line, 14 again 4 vertical line, 15 there are again 5 students are of 15 years of age. So we can again make a 4 vertical line and then one slant line. So we this group shows the 5 frequency. Like likewise 16 there are 7 students which are has a 16 years of age. So the 4 vertical line, one slant line is a 5 group, and then 2 vertical lines, so 7. So likewise we can arrange our data set in the form of discrete value and their repetitive number. The other frequency distribution table is again continuous frequency distribution table, in which there are the raw data is too bulky, and we want to arrange that data or classify that data or simplify that data. So we have to construct the class intervals or the range according to their the number. And after that, we're going to record their repetitive number or the frequency which is falling in each interval. So first of all, we have to know some term like what is class interval. The class interval, each group in which the raw data is condensed is called as class interval, and each class again is bounded by the upper and lower figure, which is known as a class limit. And the class size is nothing but the difference between the upper limit and lower limit of that class, and which is again symbolized in the form of a small I. The range is again the arranged data, again in the form of array, and then we are going to find the which is the lower number and which is the maximum number. So in a, data set, the lowest number and the highest number difference is nothing but a range. After the, if we're going to get the range of that data, and if we want to construct the continuous frequency distribution table, so we want to again know that how many uh, uh, classes we can again make in a continuous frequency distribution table. For the same, the number of classes we can calculate by this formula, like range upon class size, R upon I. If we have a data set in which the minimum number is 160 and the highest number is 172 in a raw data, so we can again, if we're going to again change the I number, the number of classes will also going to be changed. If we're going to identify I is equal to 2, then the number of classes equal to 172 minus 160 is a range upon 2. So we can again construct a continuous frequency distribution table along with the 6 classes. And if I 3, then number of classes are 4. But there is a green limitation. We can again, if we want to construct a continuous frequency distribution table, so for the same, we at least 5 classes should be there in this table, and they can max up to 15 for the easy computation of data. Again, continuous frequency distribution table of two type, like exclusive and inclusive. Exclusive continuous frequency distribution table is also known as overlapping table, in which you are finding there are classes in this table and the frequencies on the next column. And in the classes, you are finding there is again a class interval. Yeah. And in first class interval, you are finding that the class interval class size is 162 162, and the lower limit is 160 and higher limit of that class is 162. So if we are checking it, the highest limit of this class 162 is overlapping the uh, lowest limit of preceding class. So in this series, you are finding that each class upper limit is overlapping the lowest limit of the preceding class. So such kind of a table is named as exclusive or overlapping continuous frequency distribution table. So we can construct the exclusive series. And if we are talking about the inclusive one, we are finding that there is no overlapping between the lower and the upper limit of succeeding class. So in that case, there is no again overlapping in this series. So that's why is also name is non-overlapping continuous frequency distribution table. If we have raw data, so we can uh, construct whether is a exclusive or inclusive and continuous frequency distribution table. Likewise, this is again an example. We are having a very bulky data, the number, and first of all, if we want to construct a continuous frequency distribution table, so first of all, we have to again determine the range of that data set. Like in this, maximum number value is 98 and the minimum value is 0. So first, so we can calculate the range, that is 98 minus 0, 98. The second step is of this, we want to identify the number of classes by which we can construct a continuous frequency distribution table. So for the same, we are again putting that range 98, and if we want to again a class interval again 10, yeah, class I is 10, so we can easily calculate the number of classes is again are 9.8. We can round it again, consider it a 10. So uh, once we're going to calculate the number of classes, how many classes with the class interval of 10. So then we can again arrange our data set in a form of exclusive one. So like class interval is 0 to 10, 10 to 20, 20 to 30, 30 to 40, and so on, 90 to 100. And then we are going to again put number again which are coming to 0 to 10. We are going to put those values in 0 to 10 class. Then from in the 0 to 10 class, we are going to put values from 0 to 9, and then 10 to 19 in values in 10 to in the next class, then 20 to 29 values in a third class, and so on. And if we want to construct an inclusive frequency distribution table, so in that we can again arrange our classes, and the classes are 1 to 10, 11 to 20, 20, 21 to 30, and there is no overlapping in this series. Again, there is one example. We can again construct a inclusive series. Like again, we first of all we will going to compute the range, then the number of classes, number of classes, if we going to identify the class interval is again I is equal to 7, so we can easily calculate the number of classes like 36 upon 7, 5.1, almost 5 classes we can again uh, uh, classes are arranged in this table. So in inclusive class interval like 0 to 7, 8 to 15, 16 to 23, 24 to 31, 32 to 39. Classes have a 7 class interval, and the corresponding data value we're going to again put the value 0 to 7. There are 15 values. Uh, Again, frequencies are 15, almost 15 values, corresponding data values are again put in again 0 to 7. Likewise in next class, 8 to 15 values are there. In a 14, in a 16 to 23, there are 14 values. 16 to 23 values are again put in this class. So such kind of a series is called as inclusive continuous frequency distribution table. Again, the next topic is cumulative frequency distribution table. What is it? the cumulative frequency distribution table shows the running total of the frequency of the set of data. In that, adding each frequency to sum of the frequency of all preceding class. Like this is an example to explain what is cumulative frequency distribution table. We are finding this is again inclusive frequency distribution table, and where the classes are 0 to 2, 3 to 5, 6 to 8, 9 to 10, 9 to 11, 12 to 14. And the corresponding frequencies are 5, 8, 12, 6, 3. So this is again an inclusive frequency distribution table. And if we want to construct a cumulative frequency distribution table, so we can easily calculate the CF value. Like for the first class is a 5 CF, but the next class, preceding class, the cumulative frequency is the 5 plus the second class uh, frequency, like 5 plus 8 is 13. The the third one, 13 plus 12 is 25. Then if you do add with the preceding class, that 25 to 6, then is again cumulative frequency is 31. And the cumulative frequency of last class is again succeeding cumulative frequency added by this class frequency, 31 plus 3, 34. And if we're going to add all the frequencies, the summation of frequencies again 34. So we can easily check out that the cumulative frequency distribution table is again formed correctly or not. The last cumulative frequency is the addition of all the frequency. So cumulative frequency distribution table is used for the further graphical presentation. We can again graphically present this table in the form of ogives, like again less than ogive or more than ogive, and it's again easily again represent the or compare the data frequencies, cumulative frequency easily. So by this, we can again conclude that the there are some sequence for the data analysis. First step is the data collection. First of all, we're going to again collect the data, qualitative or quantitative, on the basis of their quantity, like again colony count, or their quality, like colony morphology of a bacteria, any sort of a biochemical result. So this is again all our primary data, and we can again collect it, arrange it, array, and then we going to classify it, like again how many numbers are in a colony, CFU number, or what type of bacteria, whether is a gram positive or a negative, what sort of is same gram positive is sane or a gram negative is sane, or whether it is a motile or non-motile. We can easily classify the raw data on the basis of these variables. Then first we're going to classify it, then we're going to arrange that data in a form of frequency distribution table, or a multivariate table, or a discrete table. And once we're going to classify and tabulate, we can easily summarize or visualize on the basis of their graphical presentation, like again various type of again graphs, like pie chart, or again a histogram, or a polygon, or a curve, or a bar diagram. We can easily again represent our data in a form of graphs, or we can use various type of tools to interpret the data. Uh, data. We can apply lots of again tools like average, arithmetic mean, harmonic mean, geometric mean, median, or standard error, standard deviation, or chi-square, t-test. Lots of again tools are there to interpret this data. And once we want to again interpret data or analyze this data, we can easily conclude and report in the form of like again for the in the microbiology and the what sort of a public health thresholds are there, what sort of again contamination layer, contamination levels. So we can easily uh, identify the status of that infection, and then uh, uh, form a lots of again strategies for the preventions for the cure. So thank you.